Hey everyone, this is Sayuj. I'm here to present the capstone project as part of Machine Learning Foundations for Product Managers at Duke. As part of this project, we'll be building a model to predict power plant energy output. Let's get into it. The business problem here is we need to be able to predict energy output of the combined cycle power plant. Goal is to build a model to do so. About 9,500 observations were provided in an Excel format, and the need to do so or build and predict a model or build a model that predicts this energy output is because we'll be able to optimize operations, and hence there will be cost savings. 4 features were provided as part of this data set that we have: temperature, ambient pressure, relative humidity, and exhaust vacuum. You can see the ranges of that. The goal is to predict the net energy output, which is our target variable. Now, in terms of modeling strategy, the problem type is regression. We're using regression model here because we are predicting a continuous value. Evaluation metric is going to be root mean square error. This will help us measure the accuracy, and R2 will help us see if the model we are able to explain the model variance and what kind of fit, is it a good fit or not. For this project, 2 models were built by me. One with 3 features, you can see those 3, and the other with 4 features, including humidity. So all 4 features are in the model too. Excel was the way I went with, and the data analysis regression capability, and creating 2 models using different features is the approach I have selected. In terms of our methodology or my methodology for data split, we have here 9,500 observations, like we said, and 60% of those were used for training set, 20% for validation set, 20% for test. And this will ensure that we are able to learn pattern, select the best model, and test unbiased final performance. Let's look at the results. So when I ran this in Excel, this is what it came down to. RMSE at 4.88 for model 1 and 4.55 for model 2. As you can see, model 2 has less RMSE, which is good, more accurate. R2 for model 1 is 0.91 and R2 for model 2 is 0.92. R2 higher the better. Closer to 1 is perfect. Closer to 0 is not at all ideal. So higher R2 of 0.928 is what is another factor that tells us that model 2 is a clear winner. It's a better fit, and its predictions are more accurate and closer to the actual values. For the final thing, I'll share how I did it in Excel. You can go to Excel and use the data analysis feature within that and choose regression model. It lets you choose residuals as well as confidence level. I went with 95%. And here you see the predicted PE for part of the data set. And the residuals is the difference. And some manual calculations were also done to ensure the root mean square or the standard error was accurate. And that concludes the presentation. Thank you.